This tutorial will focus on another of the four major biomolecules, the carbohydrates, which also of course play a critical role in life, particularly for structural components and also of course for energy production. Like lipids mentioned in another tutorial, carbohydrates are made up of just three kinds of atoms, and that of course is carbon, hydrogen and oxygen. And the carbon, hydrogen and oxygen are arranged in a different way to lipids and hence give you a different kind of molecule which has a different shape and a different function. Carbohydrates are made up of simple sugars, and which are referred to technically as saccharides, and more complex sugars or polysaccharides. The subunits of the polysaccharides, that is the complex sugars, are the saccharides. So this table sums up the overall view of carbohydrates, I think, very nicely. So we can see first of all in the sugars here, the saccharides, they're generally smaller molecules, so they have a low molecular weight. They tend to be soluble in water, and they're sweet to taste. Of the saccharides or the sugars, these are divided into two key groups. The group we call the monosaccharides or simple sugars, shown here, and the group we call the disaccharides or the double sugars. Some examples of your monosaccharides or simple sugars are of course the most common one which we've talked about in our course, of course, is glucose, but can also include fructose, galactose and ribose sugar. Of the disaccharides, the one that perhaps we most commonly come across is sucrose, which is table sugar, and others are maltose and lactose. When disaccharides or monosaccharides are linked end to end in long chains by glycosidic bonds, as shown here, we see that they produce what are called polysaccharides, called complex sugars. They are much larger molecules, can sometimes be made of thousands of monosaccharides linked end to end, so they have a high molecular weight. Because of their size, they're generally insoluble in water, they're very difficult to dissolve, and they tend to be tasteless. Classic examples of this, of course, in plants you have starch, in animals you have glycogen, both of which are the storage form of glucose. You have structural carbohydrates like cellulose, which make up the cell walls of plants, lignin, which is also found in plants, and chitin or chitin, which makes up the exoskeleton of insects. So these are structural carbohydrates. These tend to be functional carbohydrates in the sense that they store energy in the form of glucose. So I think that's a very nice overall summary of the carbohydrates. Let's have a look at their basic chemical structure. Again, in an exam question, if you saw particularly a long chain of molecules like this, you ought to recognise it fairly quickly as a complex sugar or a complex carbohydrate like starch, because you have individual sugar molecules linked end to end by glycosidic bonds. And of course this would extend for thousands of molecules to make up starch. Here you have a disaccharide, so you have two different monosaccharides joined together, and here you have a monosaccharide like glucose, which of course you know the formula of as C6H12O6. Of course, the main function of carbohydrates is to store energy, and of course glucose is the key molecule in respiration, and energy tied up in this molecule here, the glucose, is released through cellular respiration to produce ATP. Complex carbohydrates such as starch and glycogen can be broken back down into glucose so that energy can be extracted in respiration. And of course structural carbohydrates such as cellulose and lignin, etc., are built into the very structure of cellular life.